Hello, welcome to this video. In this video we will explain how to estimate the energy demand for hot tap water. Energy is needed for heating and cooling, for appliances and lighting, and also for the production of warm water. Therefore you need to take hot water into account when thinking of a building's energy demand. As you probably can imagine, the quantities of water used by kitchen taps, wash basins, showers and baths is dependent on the function of the building. Is it a house, an office building, a school or maybe a sports center? Each of these building types has a different number of occupants with different habits and water needs. Offices often don't use a lot of hot water because they often don't have showers that are frequently used. Employees mostly use hot tap water from taps while washing their hands. Houses on the other hand use quite a lot of water for showering, baths, hand washing, dishwashing and laundry. In the picture on the slide you can see the average percentage of energy use for houses in the EU. Water heating is 14.8% of the total final energy consumption. This is a significant amount. However, this percentage can fluctuate a lot, because it's dependent on the number of people in the house and their habits, and also on the building itself. A new built, well-insulated house, for example, has a significantly lower space heating or cooling demand than an old, uninsulated house. Therefore, the percentage of hot tap water used in well-insulated new buildings is higher, often more than 25% of the total energy use. You can see in the example on this slide, we compare a passive house with an average house in the UK. You see that the absolute quantity of heat used for hot water is identical in both cases. But because of the very low amount of space heating in passive houses, the share of hot tap water increases a lot. This means that in the future, to further increase the energy efficiency of houses, hot tap water will become more important. The yearly heating energy demand for hot tap water can be calculated by the equation on the slide using 365, which is the number of days in a year, multiplied by the density of water, which is 1000 kg per cubic meter, multiplied by the volume of water in cubic meter, this is dependent on how much water is used, multiplied by the specific heat water, which is 4187 joules per kilogram Kelvin, multiplied by the temperature difference of warm and cold water, that gives us joules. So we have to divide it by 3600 to get in watt hour. If you wouldn't multiply by the 365, you would get daily energy use for hot water instead of yearly energy use. As you can see in the equation, the volume and the temperature difference between hot and cold water are the values that we can use to influence the energy demand for hot and cold water. We also already mentioned that the volume use of hot water is dependent on the function of the building. This table shows the average hot water daily demand of the US in liters. However, this differs a lot per country, climate and culture. In the Netherlands we assume it to be 10 degrees Celsius on average, the cold water, quite equal to the average ground temperature. But of course in winter it may be colder, around 5 degrees Celsius, and summer it is much warmer, around 20 degrees Celsius. But for this type of estimate, using the average yearly air temperature of a location will give you quite a reasonable approximation of the T-cold, being assumed to be constant. For estimates of the yearly energy demand for hot tap water, this is no problem, but be aware that this will deliver inaccurate results on a daily level. For hot water, 45 to 50 degrees Celsius should be enough to deliver the required hot water demand. However, keep in mind that water temperatures below 60 to 65 degrees Celsius have the risk of Legionella bacteria, which cause a health risk. Hot water has to be produced by, for example, an electrical storage tank or a combination gas boiler. To determine the capacity of the hot water generator, we need to determine the peak load in watt. The peak load is the maximum power demand in watt. The equation to calculate the peak load is on the slide. Contrary to previous equations, we don't use the average daily volume, but we use the maximum flow rate in cubic meter per second. In residential buildings, you can assume a volume rate of 0.1 liter per second per person. For higher CW classes, in for example combination boilers, it may even be 0.16. So 0.1 leads to more or less 20 kilowatt, 0.6 to 35 kilowatt. This is why combination boilers have such a high power. As mentioned before, there are two ways of influencing the energy need for hot water: by changing the volume flow and by changing the temperature difference. To reduce the volume flow, water-saving taps and shower heads can be used. They can save up to 60% of the water. Reducing the temperature difference is not simple as it might seem. For warm water applications, you only need around 45 degrees Celsius, so you might suggest not heating the tap water higher than 45 degrees Celsius. However, to prevent Legionella bacteria growth, which causes diseases, you need to heat at least to 60 to 65 degrees Celsius. Heating the water to 65 degrees Celsius once a week should be enough, but most systems apply this temperature continuously. Sometimes also chemicals are used to kill the bacteria in the water. If we cannot reduce the temperature of the warm tap water, we can instead increase the temperature of the cold water. This will also reduce the temperature difference, and this is possible using a heat recovery system. Do you remember the heat recovery system for the ventilation part? A heat recovery system for a shower works in a similar way, but instead of using air, it uses the water. If you're showering, the water that ends up in the gutter is still warm. This wastewater is led along the supply water, which will warm it up, and therefore less hot water is needed to achieve the desired temperature. So now you know how to estimate the energy and power demand for hot water. You know that the function of the building and the habits of the users have an impact on the extent of the energy demand. You also know that the volume and the temperature difference are two aspects that we can influence to lower the energy demand. The volume we can lower with water-saving taps and shower heads. When lowering the temperature difference, we have to be careful for the Legionella risk. One option is to lower the warm water temperature to 45 degrees Celsius and periodically increase the temperature to 60 to 65 degrees Celsius to kill the bacteria. And another option is to preheat the cold water by using a shower heat recovery system.